This video discusses probability covered in Chapter 4. First, some definitions. An experiment is a procedure or process that allows us to control the conditions and observe an outcome. An experiment has a random outcome if the outcomes of the experiment cannot be predicted with certainty. A random experiment is any experiment that can be repeated under the exact same conditions and where the outcomes cannot be predicted with certainty. Probability is a measure of the proportion of times that the event would occur if the experiment were to be repeated many times under the same conditions. An event is a set of outcomes that we're interested in. The term sample space refers to all of the possible outcomes of a random experiment. We now give an example of rolling one die. If we roll a six-sided die once, the number of dots on the dice that show up on top can be from 1 to 6. If the die is fair, then these numbers all occur with the same chance or probability. The sample space of a random experiment is defined to be the set of all possible outcomes. In this case, it is the set of numbers 1 to 6. We write this as S is the set of 1, 2, 3, 4, 5, 6. The probability of an event A is the number of ways an event can happen divided by the total number of possible outcomes. So let us choose A to be the event that the number is even. Then A is the set of numbers 2, 4, and 6. We could let B be the event that the number is greater than or equal to 4. In this case, B is a set of numbers 4, 5, and 6. There are 3 outcomes in each of these events and a total of 6 possible outcomes in the sample space. So the probability of A is 3 divided by 6, or 0.5. The probability of B is also 3 divided by 6, or 0.5. The complement of an event A is the set of all outcomes that are not in A. We write this as A with a superscript of C. Remember that A is the set of 2, 4, and 6, so A complement is the set of 1, 3, and 5. The total probability of the sample space is 1. Hence we have the probability of S is 1. So we have 1 is the probability of A plus the probability of A complement. Or the probability of A is 1 minus the probability of A complement. Or the probability of A complement is 1 minus the probability of A. We can calculate the probability of A complement directly as 3 over 6 or 0.5. Or we can say the probability of A complement is 1 minus the probability of A, or 1 minus 0.5, which is 0.5. We can represent the event in a Venn diagram. The rectangle is the sample space, the dark area is the event A, and the complement is the light area outside of A. Consider some different events. Let D be the event the number is a 2, and E be the event the number is a 3 or 4. D is a set of 2, and E is a set of 3 and 4. Note that D complement is the set 1, 3, 4, 5, 6, and E complement is a set of 1, 2, 5, and 6. Probability of D is 1 out of 6, and so probability of D complement is 1 minus 1 over 6, which is 5, 6. Probability of E is 2 over 6, and probability of E complement is 4 over 6. For compound events, we have additive rules. We say events are mutually exclusive if they cannot occur together. Mutually exclusive events have no common outcomes, and so the probability of A and B is 0. For mutually exclusive events, probability of A or B is just the sum of the probability of A and the probability of B. Consider the two events D and D again. The event D consists of the number 2 and E is the number 3 and 4. So the set D and D is empty. The events of D or E contain all outcomes either in D or in E. So D or E is a set of 2, 3 or 4. Probability of D or E is 3 out of 6 from counting. If we use the additive rule, probability of D or E is the probability of D plus the probability of E equals 1/6 plus 2/6 or 3/6. For non-mutually exclusive events, we cannot just add probabilities. For non-mutually exclusive events, we have to adjust for the fact that some outcomes are in both A and B. So for our example where A is a set of 2, 4, 6 and B is a set of 4, 5, 6, the event of A and B contains the common outcomes of a 4 and a 6. So the event of A and B is a set of 4 and 6. The probability of A and B is then 2 divided by 6 from counting the outcomes common to A and B. The event of A or B contains the outcomes 2, 4, 5 and 6. So A or B is the set 2, 4, 5 and 6. And the probability of A or B is 4/6 from counting. The additive rule is given by probability of A or B is the probability of A plus the probability of B minus the probability of A and B. We obtain the same results using this rule or by counting. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B, and that is 3/6 plus 3/6 minus 2/6 or 4/6. Thank you for watching. In the next video tutorial we cover the normal curve.